heard about ANOVA control charts, that too X bar R chart. Today we are going to see about ANOM and ANOR, that is analysis of mean, analysis of range. These two things we are going to see here. Analysis of means and ranges for process improvement. Usually this ANOVA is used for certain experimental area where we want to check whether all the means are equal or is there any difference between one or more means to the overall means. So that we will be testing in the ANOVA. But here we are going to test two things. One is analysis of, that is means also we will be checking and range also will be checking. And this is ANOM and ANOR. First we will start with the experiment. In the experiment what we will be checking is one treatment is better than another. Is new chemical mixing is having any significant difference. Those things if we check. Similar things we will be experimenting. Once the experiment is done, then analyzing the experimental data is the second thing we will be doing with it. If we want to test the experimental result in this way, that is one comparing with others or any change in two means, they are comparable or anything is significant or significantly different. These things if we check and the data will be collected based on the experiment. And what all the two things we will be checking is, one is mean and the other one range. So why do we check mean and range? Mean will tell us the entire group is different or same. Range will tell that and how far it is deviated, how far the experimental values, experimental data is wider. So these two things we are going to check in this. Then we will make one graphical representation of the data, whether the values and the graphical representation are yielding the same thing or not, that we will be checking with that. So it will be easy for us to interpret a graphical representation than a numerical comparison. So graphical representation will give us quick and early results. That is why we go in for that. So here one important thing we will be observing in ANOM and ANOR, that is limit of detection. The limit of detection will be identifying it and we will be checking that value only. This is based on the alpha value, that is the decision where we may go wrong. So that based on the percentage we will be deciding on that whether we land in the right place or not. That alpha value also it will be like this. This is 1% we will be having, 5% also we can have, or 10% also we can have. Especially when we calculate that ANOM, 10% is always desirable because we take the lowest quantity of concentration and that should be accurate. That is what we expect. Even the ISO also, they have defined this, International Organization for Standardization, they also defined that this is limit of detection is the true net concentration of component in the materials subject to analysis that will lead with probability 1 minus beta, that is strength of that power of the test, to the conclusion that the concentration of component in the material analyzed is greater than that of a blank sample. So which is the lowest limit? It is 0. From 0, slightly more than that, that should be accurate. That is what we expect from that. Especially in the pharmaceutical industry or mostly in the chemical industries, this kind of detection limit are where the precision, more the high precision is required, and those areas we will be using this detection limit. Nowadays, many of the processes are concentrating on 6 sigma level of manufacturing system. That is why we go in for this ANOM and ANOR test. So when to use ANOM, when to use ANOR? The ANOM is used to determine significant difference between mean of different treatments. So mean of different treatments if we have, and if we want to find the significant difference, there will be doing. Then the chart provides visual picture of that difference can be observed from the chart. Similarly, ANOR where we will be using to ensure within treatment variation. Within treatment variation is same for each treatment. That we will be checking. So this is different. That is between and within. So these two things we will be checking here. So between we check in ANOR, within we will be checking in range. So yes, let us see what are the steps involved in doing this ANOM. First one, what we have to do, collect data by running the experiment. Collect data by running the experiment. Then we have to go for calculate the subgroup mean and range. So subgroup we will be calculating, and that mean also we have to calculate. Similarly, range also we need to calculate. Calculate overall mean and mean range. Calculate overall mean and mean range we need to calculate. Then we have to go for subgroup mean and overall mean, we have to do this. Then calculate detection limits, overall mean plus or minus ANOM, that alpha level, based on the percentage 1%, 5% or 10%, we calculate this value. Then we will go for the plot the detection limit, then incorporate ANOM chart, then interpret that. This is what we will be doing. So here we have a sample here, sample data which is given here. So 5 treatments we are making, and each treatment we take about 4 parts. The data it is given here. We will calculate the mean range 72.5 for the first one. Second treatment it is 140. Third treatment it is 60. Fourth treatment it is 127.5. Fifth treatment 82.5. So range is this range how we will be calculating it is the highest value minus the least value. Highest value is 90 and the least value is 50. So 90 minus 50 we have 40. And similarly the second treatment we have the highest value is largest value is 180 and the least value smallest value is 100. 180 minus 100 it is 80. Like that if we calculate for the fifth item it is 110 minus 60, that is 50. So grand mean, this is all the mean put together and we calculate this grand mean, it is 96.5 grand mean. Range also, the mean of all the ranges we have 56. So this value also we have calculated. So each mean, each the range and grand mean and mean range, this we have calculated. So then what hypothesis we will be having? Are there any significant difference in the treatment? That is what we are going to see. So null hypothesis will be first mean, second mean, third mean, fourth mean, fifth mean. So all are equal. So that way we assume. That is hypothesis. Null hypothesis will be all the means are equal. Alternate hypothesis, there will be they are different. So mean 1 and mean 2 are different. Mean 1 and mean 3 that is different. Mean 1 and mean 4 may be different. Mean 1 and mean 5 may be different. So that is why we have given that I. So I ranging from 1 to 5. Similarly, J ranging from other, that is 2 to 5. This will be done. So this way, this is the whether they are different or they are same. That we are going to test here. So the calculation we will do here. So the table value which we have taken, that is the Dr. Donald Wheeler. He has given the scaling factor values. The table is given here for 0.10. That is 10% ANOM value, 10% alpha value. That ANOM value is calculated, and this is the number of treatments. Number of treatments it is 2, 3, 4, 5, and in our case it is 5. And number of parts, how many we have taken, it is 4. So that is why. So for k is equal to 5, n is equal to 4, the value will be 0.540. So alpha value is 10%. The scaling factor is 0.540. This value we will be using in the calculation of ANOM value. Overall mean is 96.5, mean range is 56. So we will calculate the detection limits, or the detection limit, upper detection limit is equal to mean value plus 0.540 into mean range, that is 56. What is the value? It is 96.5 plus the multiplied value, and this will be 126.7. The lower limit will be the minus subtracted value. This is 66.3. So this is the value we got. This is the manual calculation what we have done. But sometimes people will be using the softwares like Minitab software if they use. So the scaling factor value will be slightly different. Instead of 0.54, it is 0.502. And similarly for 5% it is 0.575 and 1% it is 0.739. So only slight marginal difference is there, that we should make note of it. And when the people use Minitab, they calculate and they get back to us and asking that why there is difference, the values are different. They will be asking like that. That is why this additional information is provided to you. So now we will go for the building of chart. Building of chart, we will go for that. This is the 10% value we have calculated, and all the 1, 2, 3, 4, 5. All the 5 treatment values are given here. Mean is 96.5, and this is upper limit is 124.6, and lower limit is 68.4. The next one, this is the alpha value 0.05% value we have calculated, and slightly the mean remains same, but only thing, the upper limit and lower limit will be different. Upper limit and lower limit will be different. Similarly, this 1% value also we have calculated 1%. This is similarly that mean is different. So 1%, what happens is that the spread is more. Spread is more, but whereas for 10% the spread is very less. And now you observe here in the first 10% value 1, 2, 3. The treatment 2, 3, 4. All these values are lying outside the limits. Outside the limits. Whereas the 5%, 2 values, treatment 2 and treatment 3, they are outside. But in treatment 2, only 1, the treatment 2 is outside this 1% value. So what we observe, when the alpha percentage decreases, the ANOM variation remains within the limit. Otherwise they cross the limit. So that is what it is given. So can we accept this data or not? Yes, only except 2 and all the other places the means remain same. Only T2, the difference is there. So only T2 is outside the limit. But generally what we told that norms, what we have given, 10% is always ideally desirable one. So in that case, 3 values are different. 3 values are different. But mean remains the same. But means are all the places mean is same. So T1, T2, T3, T4, T5, everywhere the mean is same. So we accept that, we say that is null hypothesis holds good. So null hypothesis holds good. But whereas the extreme value is only, it is going out. Extreme values only go out. So now we will go for the extreme values, they go out, then what will be the result? If we go for the testing of range test we will go. The 1% we have taken, 5% we have taken, and 10% also we have taken. So 10% everywhere, see the difference is almost same. In all the places almost same result we are getting. Same result we are getting. So T1 everywhere like this, and T2, 3, T3, T4, T5. So everywhere similar results we are getting. So the chart does not make any significant difference. Variation lies within plus or minus 1 sigma level in all the cases. Plus or minus 1 sigma level, within that level only all the values are lying. So this level. So what we conclude is ANOM and ANOR, both the places the deviation is not there. So null hypothesis holds good. Everywhere all the means are equal, all the ranges are equal. So that way we will decide, we will conclude. So there is no significant difference. There is no significant difference. So if you want to hear about similar discussions, similar conceptual understanding as well as problem related examples we will be giving you, and with that example you can understand the concepts better. So training at man2succeed.com. Training at man2succeed.com. You can try and get more information. Thank you.